Okay, so today we're finishing 8.3 with day 3, and we're going to focus on complex roots today. And by the end of today, you are going to be able to find roots of complex numbers. Do you guys remember what we were doing yesterday? What were we finding yesterday? The powers, right? So yesterday we were doing powers. Today what we're going to do is find roots. So do you guys remember how you can write a root as a power? So if I had x, if I had the square root of x, yeah, good, 1 over 2. Okay, so today when we're looking at our formula, you can see that our root is going to be 1 over n. Okay, because your root is always going to be your fraction, and the power's on top, the root's on the bottom, so this is the square root. Okay, if it's a cube root, it would be x to the, yep, x to the what? If it's the third root, 1/3. Okay, and so on. So again, we have our same z, r cosine of theta plus I sine of theta. N is still going to be a positive integer. And then it has the n distinct nth roots for the given values. So notice that you're going to be plugging in different values for k. It says 0, 1, 2, all the way up to n minus 1. So if we're finding the nth root, let's say we're finding the 5th root, right? What would n minus 1 be? 4, right? If we're finding the 6th root, then n minus 1 would be 5. So, Grant, explain to me what n minus 1 just means.
You take the number and subtract that one.
Okay, or it's just what?
1 less.
Okay, so the previous term, right? So if it's the 5th root, you're going to go up to 4. If it's the 6th root, you're going to go up to 5. All right, and then this is our new formula. Should we box that in?
I think we should.
I think we should. That is true too. Okay, and we are going to be labeling these the W sub K, because you are going to have different K values. Okay, so example 1, find the indicated roots and graph the roots in the complex plane. So the complex plane is something that you guys did earlier in the week. Hunter, can you just explain to me real quick what the complex plane is? Nope, because that'll be for polar coordinates. The complex plane is what you graphed on your 8-3 intro. So it looks like this, but do you remember what the axes are? Yeah, you remember, Annika?
Isn't it like A and B, and B is the coefficient of the imaginary number?
Yep, and then do you guys remember what the different axes were called? Yeah, Lauren. Nope, because those are going to be for polar. All right, let's look at our 8.3 intro worksheet. Do you guys have that handy? Your 8.3 intro worksheet. So the very, very first page. Okay, the very, very first page, you guys had to plot imaginary numbers. And it looked like this. Okay, so then B for the x-axis, what is this? What does that symbol mean?
All real numbers.
All real numbers. So the real numbers is going to be the x-axis. Okay, and then the y-axis is now the set of what? Imaginary values. Okay, so when we say we're going to graph this in the complex plane, that means your x-axis is going to be the real numbers, and your y-axis is going to be your imaginary numbers. Okay, and we're going to plot those, like you guys said, they are going to be A plus BI form. So your A is the real number, and then your B is going to be your imaginary. Okay, so if we're going to find the 6 roots of negative 729, that's going to tell you right away what your n value is. Because you're doing 1 over n, so 1 over 6 would be the 6th root. underneath here, yes,
Yep.
yes, exactly. Yep, that's where it'll go in the formula. Okay, and then, so for step 1, we're gonna write it in polar form. Okay, so when we're writing it in polar form, there's 2 equations that we have to keep in mind. Luke, do you remember one of the equations?
R squared equals x squared plus y squared.
Good, okay, so r squared equals x squared plus y squared, and Ben H, what's the other one?
Tangent of theta is equal to y over x.
Okay, good, so your tangent of theta is equal to y over x. So for this, we just have negative 729, that's okay, we've done a negative number before. So really, if your z value is negative 729, what that means is negative 729 plus 0i. Because all you have is a real number, and then your b value is going to be 0. So your a is negative 729, your b is going to be 0. Okay, and remember a and b are the same thing as x and y, so another way we can write this is the square root of a squared plus b squared. So when I do that, r equals negative 729 squared. Do I even have to write the 0 squared? No. Okay, our r value is always going to be what? R value is going to be positive. Okay, so your r value will be positive, so this will be positive 729. Okay, so anytime you just have a number, your r value is going to be the positive value of that number. Okay, because if you're squaring it, it's a positive, and then you're taking the square root, you're going to get the same number back. Okay, so now let's do the tangent. So remember, the tangent of theta is also going to be b over a. So our b value is 0. Anything, when you have 0 on the top, when you divide that by anything, you're just going to get what? 0. So I'm trying to find out where the tangent of theta is 0, and there's going to be a couple places for that. Okay, and Allie, can you tell me one place where the tangent is 0? At 0, yep. Do you know the other one? Yeah, yeah. Good. Okay, so it's 0 or pi. Bless you. So, Hugh, can you tell me how I know which one to choose? Or if you're unsure, tell me that too. Because theta is going to be one of these two.
Since it's negative, would you pick pi because it's on the negative side?
Yeah, perfect. Okay, so he said because your number, negative 729, is negative, if you were to plot that point, negative 729, 0, you would be on the left side of the x-axis, which means you'd have to use pi. Okay, and remember, we're going off our original given value. So if our original given value was positive 729 or positive 5, then we would use 0. Yeah, then.
So what's different about this than what we've been doing the last 2 days?
This part isn't different at all.
Okay, I was making sure.
Yeah, yeah. This part isn't different at all.
Was sure I was missing something.
Nope. Because your first step is actually going to be the same thing as we did for our first step yesterday, and our first step yesterday was the same thing as what we did before. So it is the same thing we've been doing. Okay, so polar form is still going to be the same. So you're still going to have your r in front, your theta value, cosine of theta plus I sine of theta. And then I have step 2, and step 2 is to write out the general form of the equation. So if we plug that in, it's w sub k, and that's what I mean by the general form. We're going to start with w sub k, and then it's your r value to the 1 over n. So our r value is 729. We've already established our n value is 6. And then for the first one, it's the cosine of our theta value is pi. And again, you can look just right back here. And then plus 2k pi. Again, the n value is 6. And And then this is gonna be the same as whatever the cosine is of. Those are always gonna be, oops, sorry. Just doing some things loose down here. I just pretty fell. Okay, and the reason why I write the general form is because in our next step, what we're gonna do is we're gonna start plugging in values for k. And remember, we're trying to find the 6 roots. So if we're trying to find the 6 roots, we're gonna be going up to what number? 5. Okay, so one less. So for step 3, it says to generate, we're gonna generate the roots, and to do this, we're just gonna replace k with the integers, starting with 0, and then up to n minus 1. So for this one, your n minus 1 is going to be 5. So if you want to write that. Oh, I actually already did. I know. Okay, so in this case it says you're going to start with 0 and go up to 5. You should have n answers for n roots. In this case, 6. Okay, so if I'm going up to 5, I have 0, 1, 2, 3, 4, 5, 6. Oh, sorry, 4, 5. And then let's count them. So because you have 0, 0 is like the first root. So first root, second root, third, fourth, fifth, sixth. Okay, does that make sense that there's six of these all together? Because you're starting with 0. Yeah, Ben.
So we're literally just gonna replace the 1/6 with a 1/5, or and 1/4, 1/3.
Nope, not even that. We're just gonna replace the k values. So I'm gonna walk you through the first one, and the first one is gonna be w sub 0. Okay, so if we do w sub 0, if you look at your general form here, you can see your general form is 729 to the 1/6. So you can do 729 to the 1/6 or the 6th root. So 729 to the power of 1/6, and you're going to get 3. So that's what I did first. Okay, so then we're going to start with 3. Then the next part is cosine pi plus 2k pi over 6. So if I plug in 0, and you guys don't have to write the plugging in 0 part, because you can see I just simplified. But it's 2 times 0 times pi over 6. And when you multiply by 0, this whole thing will be 0. So you're just going to be left with pi over 6. And now we're going to simplify. So at pi over 6, your cosine value is root 3 over 2. If you need to, you can use your unit circle and see pi over 6, root 3 over 2, 1/2. So we're going to plug in root 3 over 2, 1/2. And then do you guys remember what we need to do from yesterday? Distribute. Okay, so that's going to be your final answer for your first root, which is w sub 0. So now we're going to do the same thing with 1, 2, 3, 4, 5. Okay, and I'll walk you guys through one again if you need me to. If not, why don't you just keep going? So you can fill them up if you're catching on and ready to go.
So it's gonna be 3. The 3 is gonna be the coefficient for all of them.
Yes, because for every single one, you're always going to have 729 to the 1/6, so that'll always be 3. Okay, so now we're going to plug in 1. Okay, so if we're plugging in 1, I'll do this part with you. Your 3 is going to stay the same. And then you're going to have the cosine of pi plus, if you plug in 1 for k, it's pi plus 2 pi over 6. reduce this, this is 3 pi over 6, and 3 over 6 reduces to what? Pi over 2. Okay, so that's why you see here the cosine of pi over 2. I have here, and then the proofs there, and then that. Yes. Yes. Okay, so then let's check our second root. So for our second root, we plugged in 2, and 2 times 2 pi is going to be 4 pi. 4 pi plus pi is going to be 5 pi over 6. How did we do with this one, with w sub 2? Do you guys want me to walk you through w sub 3? Okay, so with your w sub 3, when you plug that in, okay, this is going to be the cosine of, and then it's theta, and our theta value is pi, plus, now I'm at 3, so it's 2 times 3 times pi over 6. And then 2 times 3 is going to be what? 2 times 3 is going to be what? 6. So 6 pi plus pi is 7 pi, so it's going to be 7 pi over 6. So that's how I find that it's going to be 7 pi over 6 for both of them. And then you can go to your unit circle. And at 7 pi over 6, you have a negative root 3 over 2 for cosine, negative 1/2 for sine. We're going to plug that in and then distribute. 3/2 or 3√3/2. You can go ahead and you can think of those as decimals. So if you want to do -3√3/2 in your calculator, that's just going to help you when you're graphing. Okay, so now you know that you're going to estimate to about -2.6. And if you guys want to write those out as decimals so you have that, you are welcome to do that. Actually, maybe I'll do that with you. Okay, so when you're graphing, your W sub 0 is going to be 2.6 plus 1.5i. So this is going to be your real number. This is going to be your imaginary number. For W sub 1, it's 3i. So if you want to think of it as 0 plus 3i, that's fine. Yes, exactly. So you guys probably saw it said label, right? So label your points, and you're just going to label them with W sub 0, W sub 1, W sub 2. Yeah.
On a test, how much would a question like this be worth? I'm thinking a lot.
Well, on your test, I'm not going to make you do the six root.
Probably like a 3 or something. Okay.
Yeah.
Well, normally, is it gonna be like a rate, like point per root?
Yeah, and
Yeah.
and point for your work, so like 4, 5.
4 or 5 most.
Yep. Yep.
If you're getting an early part of it wrong, but then the rest of it would have been right because you used the wrong answer, but it was still like correct in the wrong answer, would you get credit for it, or would you lose credit for the entire problem?
It depends on what you did.
Let's just say,
It depends on what the format.
Like if I took like the tangent and I did inverse tangent, and instead of degrees I was in radians or whatever, and I used the wrong number, and so if I would have used the right number, or if I used the wrong number, everything was correct with the wrong number. Would I get all of those points wrong?
Not necessarily. The only way that could happen is, yeah, if you did step 1 correctly. But you'll be doing that step 1 for pretty much every problem. So if it was like a small error, then no, I wouldn't take all of your points. Have any of you finished graphing this already?
no.
Yeah, it makes a
Yes.
little circle.
Yes, it does. And that's actually what we were going to talk about, is how it makes a little circle. So for 2.6, I forgot the circle E.
How do you graph? Oh, those are
Yes, yep, we are going to connect them. So remember, this is your imaginary, this is your real number.
Those can be rewritten as points, right? We're just gonna point those.
Yep, yep, so 2.6, 1.5, so like an X and a Y.
Right, yeah.
Yep.
Like what we did on re-version one.
Yes, exactly. So I'm going to estimate here, and this is going to be like 1.5. And then I'm just going to label it W sub 0. For W sub 1, it'll be 0.3i, so I'm right here. This is -2.6.
So this would be graphing then on the function plane because we're graphing on the graph paper. It's not on the polar plane.
Correct.
If
Yep.
we wanted to, could we turn it into polar form? Like, would that be something that you might ask us to do?
No, if you actually flip your paper over, I gave you a graph, and it'll be just like this.